Because it's a cycle, different people will start talking about the cardiac cycle at different points. I like to start with the heart filling in something called ventricular filling. The AV valves are open, the SL valves are closed, blood's filling into the atria, pressing on those AV valves like a trap door and opening them up so blood starts filling into the ventricles, stretching them and filling them with blood. This process, ventricular filling, does not fully fill the ventricles. Only about 80% of the volume of the ventricles is filled by this passive action, right? This is the action of blood flowing back to the heart because of the pressure gradient. So, to get the remaining 20%, we actually have to get the atria to contract. The red arrows here, they indicate the contraction of the atria, emptying them and pushing blood down into the ventricles on both sides of the heart. And sometimes students are like, wait a minute, this is confusing. I thought you said that we were in ventricular filling, but we have some atrial systole. Wait, you can't have contraction during diastole. Yes, but it's only the atria that are contracting, and they're doing that to push that last 20% into the ventricles. A pacemaker node, which is not cardiac muscle but is nervous tissue in the heart, it's firing an action potential, causing the atria to contract and push the rest of that blood down into the ventricles to fill them completely. This atrial systole is indicated by the P wave on the EKG, and abnormalities with the P wave correspond to atrial issues. So we've pushed that last remaining 20% into the ventricles, and we are now full, the heart is now full of something called the end diastolic volume. So now the ventricles are full, and usually students say, oh, everything's going to contract and push blood out of the heart. Not yet. This picture shows something that is called isovolumetric contraction. Iso means the same, that the heart is not changing in volume, and volumetric means volume. This means there's no change, but a contraction is happening as indicated by those little black arrows there. That contraction is not moving any blood. Instead, it's building up enough tension, enough pressure to pop open those semilunar valves. So no blood is flowing. We are contracting. All valves are closed. So there's no movement, but we are building up pressure. How much? The heart has to generate pressure above your systolic pressure of your vessels. Recall from what you know about blood pressure that blood in your systemic arterial circuit has a pressure of 120. And that is also the pressure that is pushing back against the heart when all of these valves are closed. That pressure is keeping those semilunar valves closed. The number that the heart needs to attain, the pressure it has to generate to pop open those valves is 121 millimeters of mercury. Just a little bit more than what the systemic vessels are carrying. Think of it as a doorway. The valve of the heart is like a doorway, and there's somebody inside pushing to get out. We have our blood pushing to get out, but they have to generate enough force to push the doorway against a person on the other side, preventing them from pushing it open. I feel like there are many comedy movies where they're like, you were pushing, I was pulling. Okay, so we filled the heart, we filled the ventricles, we're building up pressure, all the valves are closed, and once we build up just a little bit more pressure than there is in the aorta, we can pop open those semilunar valves and forcefully eject blood into the pulmonary artery and the aorta. That's what these red arrows indicate. They indicate that ventricular muscle contracting. And this is what is called ventricular ejection. This is the big event of systole. The SL valves are open because we popped them open with our pressure. The AV valves are closed, allowing us to build up that pressure. Ventricular ejection is represented by this big, huge QRS wave. When the ventricles contract, there's so much myocardium involved there, and they contract so forcefully that it's reflected in this big, huge, spiky QRS wave. While the ventricles are contracting, the atria are actually starting in on diastole. And this is why we get such a big wave with all three of these points, Q, R, and S. We have a lot of myocardium in the ventricles, and they're not all having an action potential at the same time. They're having an action potential in a way that lets them squeeze blood from the heart. So it creates this QRS wave on the EKG. The last thing that happens is that the heart starts to relax again. At first, all of the valves are closed and blood is returning from the veins into the atria, and it's returning by way of that pressure gradient. When there's enough blood in the atria, the AV valves open kind of like trapdoors, and blood starts filling into the ventricles. This is the last step in the sequence that leads us to the first step that we described with the ventricles passively filling. This isovolumetric relaxation is kind of represented by the T wave on the EKG, kind of, but it's really better represented by the interval between S and T on the EKG. The ST interval is it's a pretty sharp indicator for how much your heart is filling. And remember, if your heart doesn't fill with blood, then it can't pump that blood. So the last thing I want to remind you is, remember that some books start with this step as number one step. Some books start with atrial systole as the number one step. It doesn't matter where you start this story, you're still going to go through all of the same phases of the cardiac cycle.